This lesson we're going to introduce the concepts of digital sound and digital audio. A couple of objectives here. We want to be able to identify the difference between analog and digital signals. We want to talk about sampling and sampling rates, and then discuss how those particular variables affect the actual file size and quality of the sound that we're recording. So in the world of analog, if you recall when we've talked about analog before, it's a continuously recorded sine wave signal. This can be my audio voice coming to you as a continuously recorded sine wave, or something from a musical instrument, or any kind of noise, so to speak. And we would normally in the past have recorded those on some form of a magnetic medium like a tape or potentially a phonograph record. Digital, however, works completely differently. We still have to deal with the analog wave because that's how the sound comes to us. But in digital recording, it becomes necessary to take samples, or measure, if you will, the actual points on the wave at evenly spaced time points. And these samples are represented as exact, precise numbers, another concept for which we call discrete data, data that is sampled and has a specific number attached to it. You can see here from this graphic that there is a sine wave there, and we have points that are being measured, the black dots on the wave, at a regular interval along this timeline. This allows us then to reproduce the sound wave. How accurate the actual sound wave is depends entirely on how many samples that you take. You can see in the graphic on the left is a very low sample rate, and on the right hand side we have a higher sample rate where we're taking many more points of measurement, and so we will have a much more accurate representation of that particular sound. So there's a couple of criteria. What is the sampling rate? And then there's also an idea of how much data. Again, this relates back to that concept of bit depth, 8-bit or 16-bit is typical. And then how many channels that we actually sample. When you were dealing with visual information, we were looking at red, green, and blue as our different channels. However, in audio, you can have quite a few more than that, or it can be as simple as a single channel, as in a mono or monaural recording, or stereo, which is 2 channels. So the different qualities that we typically represent recordings as vary in quality from the bottom, which is telephone, which is the least of the quality, typically satisfactory for voice only. Then we had AM radio. You can almost see the evolution of audio here as we move up. AM radio, FM radio is better, and then stereo FM. Finally we get up to CD quality, which is really as good as it needs to be for 99% of the population. And then of course we have digital video, which is above and beyond that. Of course, more than just audio, but higher rates are required to capture a lot of digital image, video, and sound. In fact, digital video requires as much as 48,000 samples per second. Most of the things that we would deal with from audio in a sense of a music or voice quality would be what we call CD quality. Your typical CD that you would buy in a store, recorded left and right channels at 44,000 plus bits per second. Here are the other sample rates. You can see they drop substantially from 44,000 down to 22, 16, 11, and a telephone is often less than 8. So how much data do we get per individual sample? This is, again, the concept of bit depth. We talked about that in the digital imaging lesson where we were looking at how many colors do you really need to describe, true color, or what we see, what our eyes can distinguish. And that was a 24-bit bit depth. Here we can get away typically with either 8 or 16. Then there's the concept, as I mentioned before, about how many channels are you going to record. If you've ever seen a soundboard at a concert or a church or some other big presentation, you know that they're recording, they're dealing with a lot of different kinds of information, multiple channels that they're recording, and a lot of different concepts that go into audio engineering. So the big trade-off here is simply file size and quality. The better the quality, the greater the file size, and vice versa. These are the actual variables. So your recording settings, you have the sample rate and the bit depth and the number of channels. That will determine the sound quality, and that in turn will determine the file size. So the more audio samples you take, the larger the audio file will be. So the size is determined by this combination of variables. Then the last thing, of course, is how long it is. The amount that you capture and how large the file will be determined strictly by how long the session is that you're recording. And that is the end of that.